Well, hey, welcome to SkyTour LiveStream here on the SkyTour LiveStream YouTube channel. I'm Mark Antonio, of course, and this is the SkyTour LiveStream for April 6th, 2019. And tonight, we say goodbye to an old friend. We say goodbye to Orion the Hunter, who will be setting further into the west every night, moving here on out. Tonight's probably I'd say the last really good night that we'll have with Orion, because we have a whole moon cycle coming up. In fact, the few-day-old moon is just sitting there. It just set with the sun, so it's actually a pretty nice night out there. So me and Gumby here, and all of you are here to join us. Let's say welcome, Happy Guy. Welcome, Evan and Justin. Good to see you guys out there already. And I'm sure we'll have a lot more that are joining us. As you can see, we've got Orion here. We're going to be playing with Orion tonight a little bit. And as the night wears on, we will move eastward, and we'll move into Canis Major over here, where a lot of things are hiding for us to see as last gasp objects before they set for the season. Now that's gradual, so in a month, the Canis Major is going to be where Orion is pretty much at this time. So Orion, tonight's probably the last night of a good Orion, because then it will be polluted by the moon. And you know us astronomers, we don't like the moon, man. Alright, I want to say hello to Bonnie, who just joined us. Hey Bonnie, how you doing? And Marianne Robb, nice to see you as well. And I'm just really happy that you guys could join us. It was interesting. I met Bonnie actually out in Laughlin this past week. She is a kindred spirit of astronomy and all kinds of neat things that I was talking about actually for my talk. So it's kind of cool. Of course, then Marianne was there as well. She showed up from Arizona. She came out to say hello with her friend Joanne. and no less names. And Dave Rich. Oh, Dave Rich is with you, Marianne. That's cool. Dave Rich and Marianne are both police officers in Arizona. They're very good at what they do. Sorry for my cough. And I call them friends because they're the kind of people that it's really good to have on your side, number one. Plus, they're just really nice people. So it's nice that they're here. Dave Rich, I'm going to say hi to you because you're not typing, but that's okay. I guess Marianne is monitoring things for you, and that's okay. So as I said, we're going to look at Orion, and then we're going to move our way eastward, and we're going to go into Canis Major and take a look at some of these objects over here. And I know in past nights, in past nights, we've actually looked up in, this constellation here, which is Leo the Lion. You can see it very simply by doing this, and we turn on the mythology, you can see it. And this mythological beast in the sky is dominated by Regulus down on his lower chest or paws. That's the brightest star in Leo, the lion. Okay, and then back over here, we come back to this unicorn, this dog, and this dog down here. See, this is the kind of the winter sky. This is the small dog that's called Canis Minor. All right, this is Monoceros. Okay, one horn, Monoceros. And this is another location where there's lots and lots of cool things. In fact, there's a beautiful nebula right here in the snout of Monoceros that's called the Rosette. But it's faint. It's a little bit faint. Might be a little hard to see. So, but then down here we have a ton of wonderful items in Monoceros and Canis Major. All right. And then we also have some really interesting stuff down in here, which is very low in the sky now at this point. But these are places In Puppis, it's called Puppis, right? And it's Puppis, the poop deck of the ship, okay? And so when we look down here, I don't know if we'll be able to see too much there, because that puts us way low in the western sky now. So we'll still look and see what we can do. Hey, welcome Carolina Sky Astronomy, and welcome Maddie. Thanks for showing up. Good to see you guys here. Sorry. All right, so let's focus on Orion, since it's gonna go first. We've seen Orion, the hunter. Here he is, and looked at Orion quite a bit, and to Orion's right, no longer viable for us to see, is Taurus the bull, with this red center of the bull's head, or eye of the bull. This is Aldebaran. It's a very large star, okay, and it's a type K5. That means that in the hottest to coolest range, it's next to the last, so it's more cool. So the letters that describe it are O, B, A, F, G, K, and M. We are a G star. We're a G5, a G2 star actually. Okay, and there's another what's called a luminosity class that's associated with each star, and it has to do with what part of their evolution they're in. We're a G2 Roman numeral 5, so that's a V. And the Roman numeral 5 means normal hydrogen fusion, making hydrogen into helium. Okay, well, Aldebaran is a type Roman numeral 3 luminosity class. So when I look at Aldebaran here, that 3 tells me that we're looking at a giant star. Okay, now it's also a K-type star, K5, so halfway between 0 and 9 on the scale. They go from K0, K1, all the way through K9. No, not like a dog. But the K5 is right in the middle, and it's in decreasing temperature. K9 is cooler than K0. Okay, so G2 is cooler than G0. I think we're the coolest of all, though, don't you think? I do. But our planet may not be the best and most habitable of the planets in the universe, believe it or not. We do have other options that may present themselves as we find others. But focusing now on Orion and removing the mythological views, I'll leave the constellation lines because I think that's kind of important. Right, we're actually down here right now. We're in the dagger of Orion, below Orion's belt. So we have these 4 stars here, which many of you know, Betelgeuse. Okay, Betelgeuse is 490 light years away, and it's going to go supernova. It's a red giant star, all right, and it's quite massive. And then we have Bellatrix over here. All right, Bellatrix is not going to go supernova, but it is a giant star. Okay, Betelgeuse, on the other hand, is it's a type M, so it means it's very, very extensive and large in diameter. Okay, and the colors of the stars and their temperatures dictate what their spectral class is. So of that O, B, A, F, G, K, M, O being the hottest and bluest, M being the coolest and reddest. And so when we look at Betelgeuse, we're looking at an M-type star, so it's very cool. And it's a 4, M4. And so it's partway through the M classes, and it's a type Roman numeral 1b. So that means that it's Roman numeral 1b for its brightness class, or its evolutionary class, and that means it's a supergiant. All right, if you put this star in our solar system, it would likely all the way, extend all the way out to Mars. So that said, we move to Bellatrix now. Bellatrix is another giant, but it's a B-type star. So it's very hot. Only the O stars are hotter. All right, and then we come down to Alnitak here, which is the leftmost star in the belt. Let me zoom in a little. Okay. We have Alnitak here. Alnitak is a very bright star, all right, and it's an O-class star, O-type star, so O9, as a matter of fact, O9.5, and it's a supergiant. So this star will probably go supernova as well, all right. These stars like this, like Betelgeuse, they only last a few 100 million years. So I think that it's pretty cool. Next in line is Al-Nilam. Al-Nilam is another very bright, very hot star, but it's a B0 supergiant. All right, and then Mintaka out here. All right, and Mintaka is an O9. So these three stars are very hot, very young. And when Lucy, Australopithecus afarensis, our primitive hominid ancestor, 4.2 to 4.4 million years ago, was strolling around in the African savanna, one of these stars may not even have been there yet, right? Because it appears that possibly one of these belt stars wasn't there because it's a recent development, all right? So that's very interesting. Now, coming down into the dagger, we see the dagger, and don't worry about the dome cams. That's actually supposed to be not there right now, so there, I'll take them out. And now, if we look, here's the Orion Nebula in the dagger. All right, it's a beautiful stellar formation location. But let's keep going, and we'll come down to Rigel here. Rigel, very hot blue star. All right, it's 862 light years away from us, and it's extremely bright. All right, and it's also a B-type star, B8, as a matter of fact. But it's a supergiant, a B8 Roman numeral 1A. You have 1A and 1B for the giants. In these, that's called the luminosity class, the Roman numerals there after the stars. Okay, and then we have Saiph way over here. Now Saiph, Saiph is probably a little more different than the rest because it's a little bit less brightness. Okay, it's a B0, so it's a bright blue, and it's a 2, type 2. It shows you right here. See, this right here is the luminosity and spectral class. The spectral type, the spectral class here, that is what letter it is and what number designation within there, plus this luminosity class gives us the overall spectral type of the star. So you have the spectral class and the luminosity class. Two classes give you a type. So class plus class equals type. All right, so we have spectral class, we have luminosity class, and the spectral type then is the two of them together. So that works with any star in the entire universe. But enough of this stuff here. Let's go image. Let's go check out the Orion Nebula before we lose it for the rest of the season. So heading over to our visibility, and I'm gonna just do one quick thing here just to bring these back. I have to just bring our dome cams back. There we go, and then I'll just bring those up. I want to make sure that we have those because we want to see what the dome is doing, right? So this is this is the Orion Nebula. Keith is here from P&K Space Imaging. If you haven't subscribed to P&K Space Imaging, please do so. Keith, throw your link up if you would in the chat so people can dump over there and have a look at you. And don't be put off by him, folks. He's really a good guy. So this is the Orion Nebula as we see it here in the telescope using our sensitive camera. But if we really want to look at it, cool, we can actually turn on what is actually a 4K video acquisition. And I just shortened to 4K video mode. So right now we're capturing this in video. We've seen satellites come through scenes during this time and more, so it's pretty cool. So if I increase this characteristic here, for those just joining us and who've never seen this before, okay, this down here is the operations group. This is me. Hi there. Okay, these are the dome cams that are active inside the dome. You can see the telescope. This one, camera's riding on the barrel of the telescope, pointing out of the dome, and this one is back in the observatory, looking down low, looking up at the telescope. Okay, this is our telescope control system over here, and this is the camera control system. So these different clusters do all different things. Okay, so we're gonna actually we're gonna move the Orion Nebula down just a little bit. Okay, and see, I'm controlling the telescope. I took the time to focus already, but I do have a focusing mode. So if we want to focus, I could just zoom in. All right, and I can actually focus on the nebula. This also, by putting it here and centering it in this view here, it actually centers it in the telescope. I made sure that this is center. So then we turn that off once we're satisfied, and I could focus down here using these buttons down here in the bottom of the telescope cluster. So here we go. This is the sensitivity of the camera, and this is the exposure of the camera. So I'm going to turn off the video mode, okay? And with the video mode being off, we can now say, let's go to 6400 and do 8 seconds. Let's just try that. So we'll do that. So an 8-second exposure at 6400 sensitivity. Now this camera can go all the way up to 409,000 sensitivity. But you also get a lot of noise. And noise, it's no fun. So we balance this. If you've seen any of our photos we've taken before, SkyTour LiveStream has been very successful in showing you some very cool sights. Pictures underway already. You can tell because, there we go. Now this is beautiful. This is the Orion Nebula, folks, for those who haven't seen it. We actually haven't seen it lately, have we? This is a gorgeous, detailed nebula. And I did some calibrations on the telescope to actually help focus it better. And here we go. And now we have this better focus. Now this granular look, this grainy look, this is because of the sensitivity on the camera, right? If I want to turn it down a little bit, right, we might be able to do even better. So let's try this. Let's go back to our view here, and let's take the sensitivity down, way down. Let's go down to say 2000, okay, 1600, and let's take this up to 20 seconds. All right, now let's see what we get. You'll see a lot less noise. And you'll see a similar photo. It'll be a little different. Right. So while that's doing that, I want to say hi to Shep, who joined us. I want to say hi to Ronald from ERRT Radio, who's joined us here. Ronald's going to be in Pine Bush with us. He's going to be joining us. Patrick Webb, thanks for coming. Good to see you. And Dalai, thank you. All right. So now, here is the Orion Nebula with less noise. You see how this? We got a little streaking going on, by the way. See that? Those aren't UFOs. That's actually the nebula was streaked a little bit, and I apologize for that. But I shall fix it. Okay, so we're gonna go back to our photos, our photo capability, and let's do another photo at 20 seconds. All right, and we should see, and you'll notice taking a photo when this L is blanked out. That's just a little thing you get used to seeing. All right, and then when these things come back and change, it means the photo's done, and it'll jump us over to the viewer, which we'll see in a minute. So if you keep watching, you'll note, there it goes, see, and now we're over here, and this one's also streaked. The other night when I had Daryl on, we talked about training the telescope to recognize the longer exposures and to guide better. Well, it's been windy here, and so we do have wind, and there's also something called periodic error, and periodic error in the drive will cause these streaks. And that's something that we have to manage. And I'll just answer some questions here. I see, okay, Bonnie Stanley is saying, is that gases? Yes, that is. And if this picture comes out well, I'll take the time to explain what we're looking at. Carolina Sky Astronomy is already doing so, which is wonderful. Thank you. Okay. A little better, but it looks like it might have little tiny walking, I call it. So one more, because I'm a fussy guy and I got to get it right. Okay, so you'll see red and you'll see blue. Okay, and while we're waiting for it, let's actually go over to this. Okay, this is the the nebula so far. Here we see red, and we see some blue in here. Okay, I love this area of the Orion Nebula right here. And when the new one comes in, by the way, it's just going to overlay this one. And scroll it all up. See, here it comes. There it is. Okay, and this is a far better shot. Look at that. Look how sharp those stars are. Let's zoom in. Oh, look at that. So you can see these 4 stars right there. 1, 2, 3, 4. Okay, and then 1, 2. You know, and see, here's the thing. Let's zoom out a bit. Now you see this beautiful area right here. Now we've shown this in a lot more detail than this, but right now, for elegance and getting a beautiful view, this view will suffice. This area is actually a blue area. It looks a little brownish right now, but it's actually blue when you do a little processing. And this area here, red, and this blue here, these are all related to the elements or atoms that are in this nebula. Now, most nebulae are made of hydrogen. Okay, let me just take a little sip here of this. Hydrogen is the most plentiful element in the universe. And it's also one that is responsible for the red color in nebulae like this. Alright, now we should see a couple others that are brilliant blue a little bit later. I'll show you. And blue can be one of two things. Okay, the blue can be reflections of hot blue stars reflecting off of dust. Alright, or it can be the result of atomically excited, it is by radiation, oxygen atoms in a nebula. In this case, we're seeing oxygen atoms over here and in here that were in the interstellar dust cloud here before these stars right here were formed. And there's a lot of other stars forming in the Orion Nebula. This is called a stellar nursery. There's so many stars forming in here that we can't even see them except with infrared telescopes. Infrared telescopes can show us these little hot spots all throughout the nebula where stars are forming. And these areas here, this is dark dust. And this dark dust is actually in front of the brighter nebula behind. See, this continues right here, but this dark dust is in front of it. So you got to remember, we're seeing this in 3D, okay? But our eyes are only seeing it as 2. So 2 dimensions to our eyes, 3 dimensions in real life. So this is closer to us than the stuff behind. Cool, huh? I think that's pretty cool. And so if we and I won't go through the hydrogen transition to make these red lines, but red colors, but I'll tell you what they are. When you have hot blue stars like these in hydrogen gas, what is hydrogen? Well, hydrogen is a proton and an electron. That's this cloud around the center, around the nucleus of the atom. Well, if you hit that atom with ultraviolet energy, that electron starts to get it absorbs some of the energy, and it moves farther and farther and farther away from the nucleus until it is literally not bound to the nucleus anymore. That's called ionization. And so ionization occurs in the nebula, and then electrons have this funny thing they do, that when they leave an atom like that, they might collide with other things in the interstellar medium, and they lose energy because they gained energy to leave the atom. But when they recombine with the atom, they jump down to various levels. And the things are, in atoms, there's discrete levels. You know, there's atoms at what's called the N as a name, N or a number. You know, the N level, and the red color is due to atoms dropping to the N equals 2 level, so very close to the nucleus. All right. And that actually has a name, that series of drops, you know, into back when the electron comes back into the atom and recombines with the atom and drops to level 2. All transitions from other N levels in the atom down to level 2 is called the Balmer series, Balmer, and transitions down to N equals 1, the first level, is called the Lyman series, Lyman. And so they're responsible for different things that you see. But in this case, we're actually seeing we're seeing the red color that's a transition to the energy state number 2 in the hydrogen atom from anywhere else above, right down to and energy level 2 is what makes this red color. And that's the characteristic light that's given off, because when an atom loses energy, or an electron loses energy, it gives off light. When it gains energy, it absorbs it. So it absorbs ultraviolet light, ionizes off the atom, recombines with the atom because it collides with something out there to make it start losing energy. And as it comes down into the n equals 2 level in that hydrogen atom, it gives off this characteristic red light. And that's how we identify what we call hydrogen 2 regions. And it has nothing to do with n equals 2, the energy level. It has to do with the fact that it's ionized hydrogen. Now, I've said this before. The hydrogen 2, the 2 is a Roman numeral, okay? And there's hydrogen 1 too. So there's a hydrogen Roman numeral 1. What is that? Well, that's just the hydrogen atom with its electron, the base state. That base state of a hydrogen atom is given that nomenclature. So when you do a H2, that's a singly ionized, in other words, ionized only once, atom. Now, you can't ionize a hydrogen atom but once, because of course it only has one electron to ionize. Helium, on the other hand, you can, and carbon, nitrogen, oxygen, fluorine, all the way on up, you can ionize as well. And there's some ionization states that are better than others. Hey Tim F, welcome, good to see you. And some ionization states that are only quick and transient. Okay, but this is the Orion Nebula, guys. This is a stellar birthplace. It's about 1,400 light years from the Earth. That's why we can see it so beautifully. Okay, and these 4 stars are called the trapezium. And I actually want to show you those a little bit better. So hang in there for 1 second as I bring us back. I'm gonna now just do a shorter exposure just to show you. Okay, you'll notice that the screen's getting dimmer. Okay, but I'm just gonna do a 1/10 of a second exposure at 1600. Okay, that'll be quick. Look at that, it's already done. All right, and there's the trapezium. These are the 4 stars that are lighting that part of the nebula. Look at that. These are 4 very hot young stars, and they're gravitationally bound. So that's something that's really interesting. That the 4 stars can be gravitationally bound, because that's actually an inherently unstable system, unless one orbits another, and then those 2 orbit another pair. But they exist. So, and Bonnie, I want to thank Fantasy Ecstasy. Thank you. So good to see you too. And Dave Schmidt, great to see you. I want to thank Fantasy for mentioning that. It is indeed oxygen that causes the blue. Different elements are present in the interstellar medium, and the way it works is that when we look at stars are element factories. They make all this stuff. Okay, they make all these elements out there, and it's really quite astonishing. All right, how many they make? They make, obviously, we have a whole periodic table, remember, and they actually make all the way up to the full extent of the periodic table, minus the ones that we've created in the lab. Okay. Now, to show you the full extent of the Orion Nebula, I'm gonna do I'll do 15 seconds at say 5,000. Okay, so let's do that, and I want you to see the full extent of the Great Nebula in Orion. It's really massive. It's very, very large, and you see this you see the small core here. Okay, and you saw the other stuff that's there, but there's a lot more to it, and we should see that. Shortly. I apologize for my cough. I just started getting this cold today, so I apologize. Okay, that's not helping us, but this will. Okay, now you see the color a little bit more realistically. Check that out, right? And you can check it out better if I just get rid of all the gobbledygook there and give us a private view. I'm also going to do one other thing, because I like doing this, and this is something that the regulars here are used to. We can actually do some on-the-fly image processing, which is what I'm doing. Okay, so here we go. This is the Great Nebula in Orion. Look at the colors in here. Okay, note we have this one up here. Okay, this star is powering that one, and it's mostly making this H2 region, or hydrogen Roman numeral 2, which is a diffuse red nebula. That's the result of the hydrogen dropping into the atom, hydrogen electron dropping into the atom to level 2, energy level 2. You can also see the blue very well in here. Okay, you can see the blue oxygen in here. You can see the many stars that have come and gone in this nebula. All this gas in the interstellar medium was made in stars. All of it. Every last bit. Okay, the hydrogen fuel this hydrogen that's in here might have been a holdover from the formation of the universe. But we're looking at it then at a point in which it's actually come to this nebula, come to this actually region of space, and I have to zoom out for this. This entire area, in fact, so much larger than I can show you in the telescope. This entire area is actually one that's it's actually an area that's actually this is like a blister on a gigantic cloud of gas and dust, and the gas in much of the locations is actually 2 atoms of hydrogen together, diatomic hydrogen, and that's actually a molecule. So much of the dark you see here, you see what looks like nothing, right? It's not nothing. Look, there's dark dust. This dark dust is actually in this region. Okay, it's in this region, and here you can see it kind of looking or leaking a little bit over onto this cloud. And here's something else for you. Look at the stars. You see how the stars look a little bit orange? See, orange and orange inside here. You know why? Their light has been extinguished a little bit by the gas and dust that's between us and them, so they look reddened like the sunset. So we see that happening in space as well. Depending on, it's not atmosphere. Didn't want to rate that, but okay. It's not atmosphere, but it is definitely a medium through which the light's traveling, and it will do what's called extinct. It's called extinction. It'll cause the light to be diminished somewhat. All right, and that's what we see, and it gets reddened when it's like that. All right, so the Orion Nebula is really a phenomenal location, and it's right in our backyard astronomically because it's only 1,400 light years away. Some of the other nebulae are 8,000 light years away. I think like the Lagoon and so forth. Let me just do this. Okay. And so, and you also have to be careful because some of the red dots that are in the view are actually hot pixels in the camera. Like, let's see. All right, this one I believe is a star. We can confirm that by taking another picture, but I mean, look at the delicate nature here of this. Isn't this gorgeous? You know, delicate is beautiful. It's just so gorgeous. All right, let me just come back now to my stellar thing here. I'm going to do this, bring up the telescope cluster, and I'm going to bring us up for a minute. All right, the telescope is now steering out in the dome. Okay, you can watch the dome move if you want, or watch the telescope move. And now I'm going to do 6400 at 20 seconds. All right, and if the wind is calmed down, we should be able to do this without any problem. We tend to be able to get away with it. Oh, Dave Schmidt asks a great question. When parts of the cloud reach other stars, would those stars' gravity pull that gas in, or would their radiating force push it away? Actually, Dave, the question depends on a number of things. First of all, it depends on how fast the cloud might be moving, because if the cloud is moving at any speed, it could possibly overcome the radiation pressure. But the fact is that most of these clouds, most of the stuff is actually being forced away. And that's why, for instance, when you look at star clusters out there, okay, in space, and we look at them in astronomy, we might find, okay, that the star clusters have gas on the outside of them, but none in the middle. The Rosette Nebula is an example of that. And what's that mean? It means that the stars were hot and young and were blowing a lot of this gas away. And they probably initially caused it to fluoresce and glow by this ionization process we mentioned. But later on, as the stuff dissipated, it would glow less and less and less until finally it would glow no more. And that's what happens with some of these star clusters. Star clusters are all born in these places like this, right? They're all born in stellar nurseries, as we call them. But then they may destroy the stellar nursery with their own radiation pressure. And that's kind of what we see. Hey, Melanie, thank you for coming, and thank you. That's very kind. I'll feel better. Look, it's what you get, when you run out to a dome every little while just to make one more correction. Let me just do one more thing. For those of you that have been here for the last few nights where we were doing this, you know that I would run out to the dome, come back in, and then I'd want to take one more picture. And by the time I kept saying, okay, just one more, what did we end up with doing? 5-hour streams. 5-hour streams. I was like, wow. But you have to understand, too, that last year at this time, I was in the dome doing this because I didn't have the remote system set up. You're seeing the remote view. When I show you this view here, okay, this view here, what you're seeing here is you're seeing the control systems on these two monitors. All right, and also over here you're seeing the chat. Okay, I'm seeing Skype communications for when Amanda comes in. I think she's off doing something else tonight. And then I have the music up there because I always think that music makes things better. Music's it's kind of nice. It kind of helps things flow, and I've always done that. Even when I do talks around the country, I actually will, try to play music, and most times they don't know what to do with my music, so they don't play it. They have no idea how much better it would be with music, and the music's soft. It's not glaring and blaring in the background. Oh, Gumby just took a header. Gumby jumped off the edge of this here. So that said, let's do this. Okay, let me take us up now because I actually want to do one more thing here. And tonight we got a lot we can look at over in Canis Major as well. Now you might say, well, why are you going up? Dude, you're leaving the Orion Nebula behind. Why are you doing that? Okay, well, I'm not really. Okay, let's do 20 seconds right here. I'm going to actually bring it down just a little bit. Like context photo, okay? So the Orion Nebula is down here, and there's something up here that I want to show you. So let's do 20 seconds at 6400 and see what we get. Yeah, I'm using some of Kevin's stuff, David Schmidt. Hey, Dude W, what's going on? Thank you for coming out. And everybody give Bonnie a warm welcome. I think this is the first time she's been here. Okay. Alright, so this photo's working well. Let me just get the view proper. There we go. So, and let's process a little. Alright, so what we're looking at here, okay, is I'm going to just do a little more processing just to give it a little better punch. There we go. That's good enough. Okay, so now what you're seeing here is a blue nebula with a little bit of hint of red. And down here, you notice how this blue is a little bit different than this blue? This blue is not quite this blue, is it? This is sort of a turquoisey cyan color. This is the characteristic color. It's an unearthly greenish blue. And it's the characteristic color of the oxygen atoms that are glowing from this ionization process, because they too get ionized. Their electrons jump off Okay, in fact, it's doubly ionized oxygen doing this, and then those electrons recombine with the atom, in the nucleus rather, and they give off this characteristic bluish green, you know, really ghostly light. But then there's this. This one here is just more of a blue color, all right? And now that you see the difference, let's go to that nebula and check it out directly. Okay, so bring up telescope controls, bring everything back, and now let's just go up to that nebula. All right, so now let's get an idea of what we're looking at here. So let's take it up a notch. Let's go to 12,800 ISO for 20 seconds. Okay, right here. Make sure that this is stable. We're stabilized. Okay, and let's go do this photo and see what we get. I'm going to show you this area now. So this area now, which you'd never see this object without either a dark sky and binoculars or a telescope. This area is the nebula that's known as the Running Man Nebula. All right, and you can see it here, and let's process it. I love this instant processing that I can do for you guys, because and there's a few things happening which I'll talk about. And first things first. First thing is I'm going to bring up my colors and my contrast and so forth, and I'm going to give us a little bit more contrast in here and processing to be able to show this color. That's pretty good. So here, now you can see this blue, right? This blue is a different blue from below, as we said. So what is that? Well, this is exactly what we talked about before, when the bright stars are just reflecting their light off of dust. Notice how you see this cloudy nature right here? This almost looks three-dimensional, and because you can actually kind of see it. This is an area of space where this dark cloud is between us and this nebula behind, and so it's being illuminated on its edges by the bright area behind it. Isn't that cool? You can almost see how this is before it, and you dive into the nebula beyond. I love this stuff. So, in any case, so this is the Running Man Nebula. Hey, it's a lot of fun to see the Running Man, you know. So I'm really happy that I could show you that. And now I want to take us over to our our planetarium, and I may have to move the dome in a little while, but not right now. I think we're cool right now. What I'd like to do is to take us now from down here. I'm going to take it here too. This is a really cool little nebula that often goes unnoticed. Okay, it's called the 13th Pearl, but it's also known as the Rubber Stamp Nebula. It's also known as NGC 1999. What does that mean? Well, I'll show you. The NGC means New General Catalog, and the New General Catalog is actually a compilation of thousands of objects that are pretty cool. And as we pull into this location, we'll see that the sky and the telescope has stopped moving. Right, and you don't see anything down here. You go, what's there? I don't see anything, and you wouldn't. Okay, unless you did this. We took I bet you we can catch it with 15 seconds at 8,000. So now let's take 15 seconds at 8,000 and check it out. The dark cloud that you see, the dark cloud is actually dust. It's not gas, because gas is neither dark nor light. That gas is, by its nature, transparent unless there's an awful lot of it. Then any inherent colors will be will be visible. Yeah, we can kind of show it here. It looks like we're seeing it. Let's jump in here a little bit. Alright, I'm going way too close right now just so I can zoom it out a little bit. Okay. Where'd it go? There it is. So this is the object I was trying to show you. This guy right here, alright, who just vanished on me again. There he is. Here's another star that has sort of a reflection nebula around it. But look, there's a dark one in here too. This dark object right here. What is that? Well, that's sort of a black dust cloud that's actually orbiting as well in here. Isn't that cool? And you know, that's actually exactly the kind of thing that you know, just gets us astronomers all excited, because there's so much you can learn from a little cloud like that. A little tiny cloud way up there. All right. Actually, I've got something on that I want to get rid of here, but hold on. There we go. And let's now go back here. Go to default. There we are. Here we are. Now, Bonnie, she's asking if it could be antimatter. No, it's actually dark dust. We know how big it is. The dust is only a few microns across. They're little grains. And when things like that form in space, they take on a different shape than dust we see, like in our living room in the sunlight. Okay, these are tiny little tiny grains, which might actually be spindles. You know, little spindly type grains. And if you think about it, Oumuamua was a very large spindly type grain, but it was an asteroid, wasn't it? Well, so they say. You know, I did a ABC special with and Avi Loeb was on it, who's the Harvard astronomer, and Douglas Trumbull and I are friends, and we did a special not too long ago, and Avi Loeb said that Oumuamua, he thought, could be, and there's no reason to say it couldn't be, an old spacecraft that had been created by an alien species and sent on its way. I guess in the same way that someday when our Voyager 2 probe reaches somebody out there, they'll look at it as it zips through their solar system and say, what was that thing that went through? Do you think it could be a spaceship? Nah, it's probably just a little asteroid. See, so now you're that's kind of where you go with that. You know, you end up seeing the other side of the fence when it's us. Hello, Stacy. How are you? Welcome. I'm glad you're enjoying us. Oh, Harry's here too. How you doing? Oh, you Harry's talking about the jet shooting out of. Yeah, we showed a very active radio jet out of Messier 87, which is a gigantic elliptical galaxy. And it was interesting, and you know, it wasn't very. It was very small, okay, but then again, this telescope is meant to show us views that are kind of extensive, you know. If I got a regular telescope, we would not be able to see the entire Orion Nebula as we do. You know, when we look at the Orion Nebula, okay, we actually see this, you know. This is beautiful, all right. But with a telescope that's got a lot more, well, a longer focal length, it's called, you know, an f10, we'd only see this part. We wouldn't get to see this entire nebula with all this area around it. We'd only get to see this middle part. This gives us a great context. I love this. So, that said, so back down here, this is our little nebula. I also want you to notice something too. Notice how when I select one of these pictures, you see how these little rainbow colors are all in the picture and then they seem to go away? Okay, yeah, that's noise processing that I'm doing in the background to get rid of a lot of the noise in the image. The idea is to try and make the image as beautiful as we can make it for you right here live. I think that's the beautiful part about all this. You know, it's a lot of stuff to do up front to make sure that all happens, and that's okay. I don't mind that. I think that it's great because you know what? I want you to come away from this saying, wow, I did not know that the universe was so beautiful. Okay. So this is what we do. See, we do this. Albani, she asked, what created the spindles, meaning the little dust, the micron-sized dust particles? Well, they're created out in the interstellar medium, in the vacuum of space. So that is the shape that tends to form. And the dust particles tend to form out there like that. The other thing that happens is they can cause other effects. You can actually see polarization of the light coming from stars, like polarized sunglasses, okay? Because the spindles are aligned in one direction or another. They could do some odd effects like that, you know. But look at this, is gorgeous. You can actually see this three-dimensionality of this cloud pretty well here. I think that's pretty nice. And again, that's between us and this nebula behind. Unbelievable. So, that said, let's go back to our planetarium. I like integrating this planetarium. I hope you guys enjoy how I integrate, because I think this is a very good way to instruct people. See, up near the belt of Orion now, we're going to go look at something up here. Okay, and this, I'm going to grab my indicator here. This indicator basically is the size of my frame of the camera, right? And the angle at which it'll be. So now I can just tell the telescope to go to that exact location. And so when I go back here, you can see our stars moving now. We're pulling in to the area around Alnitak, which is that star in the belt of Orion that is right there. All right. So now we come back here, all right, and check our. There we go, and our telescope stopped moving. I'm gonna come down here, like this a little bit. Okay, bring it down. Okay. I'm a little tired tonight because I had to drive to Rhode Island, which is next state over, and back a little earlier. So it was a long day. Okay, so 15 seconds at 8,000. I'd rather do 15 seconds at 12.8. Okay, so here we go. We're gonna try this. Oh no, I'm gonna do 20 seconds. That's right. And I want to do it at 16. Okay, here we go. I want you to see the interesting object that appears here. You've seen this before, some of you. Carolina Sky is asking, am I doing live stacking? Actually, I'm not. I don't do that live, but I do some on-the-fly processing of single images. Okay, and the on-the-fly processing is important because I want to be able to show you what the raw frames look like. Okay, so this, what we're looking at here. All right, it doesn't seem like much, but there is a shape in here. Can you see that shape? And now let's go pull it out with our little instant processing. Now you can see all this feathery shape here with some other shapes out here and out and around. This is actually called the Flame Nebula, and it's to the left of Alnitak. And in fact, Alnitak is causing the Flame Nebula, which is hydrogen, to glow like this. It's ionizing it. The electrons are bouncing off the atom, rejoining the atom, and as they do, they give off red light. And that when they rejoin the atom, that's actually special. It has a special name. It's called recombination, when electrons rejoin their atom. So that said, I think this is really nice. This is the flame, and I use the flame as an indicator of what the night's like. And Orion is actually kind of low in the sky right now. So when we come here, okay, you can actually see that Orion is down about 20 degrees. We're looking at about 20 degrees, 22 degrees above the horizon. You know, there's the horizon. So it's setting. You know, it's almost setting. And what I'd like to do is to take us now eastward to some of the other things that we can look at, maybe in Monoceros. Oh, but you know what? No visit's complete without visiting a star that may very well have already gone supernova. And that's this star right here. This is Betelgeuse, and let's get to it. There's Betelgeuse. Betelgeuse is that red supergiant that I told you about before, and it's actually quite a interesting star because it actually has these large areas on its surface that are just bubbled out, that look like these unbelievable bubbles, like giant convective layers in a boiling pot of water that are frozen in time. But they're not frozen in time. You know, they're not frozen in time. I'm just reading the chat quick. My lungs are clear, actually. This is something that's it's a change of season cold that I always get, and I'm not gonna let it stop me from doing my thing here. I never have, but thank you. All right, so let's take a look here. If I were to take it, let's just take a shot, just a setup shot to show you just what the area around Betelgeuse looks like. We'll go to 8,000. Let's do 15 seconds at 8,000, and just show that real quick. It's just a beautiful area, you know. So I'll tell you. There we go. There we go. Look at that. Isn't that pretty? Just a beautiful area around Betelgeuse. And I just think it's really stunning. Really stunning. So we can take that back a little bit too. Let me just pop this off here. Bring this back. Here we go. Yeah, so I spent a lot of time calibrating the telescope to get beautiful star images. So now we actually have some beautiful star images. The stars are pinpoints. They used to have little tails on them, and I managed to take care of this to make that go away. Here's something too that's interesting. Let's let's just do this. I'm gonna come back here for a minute, okay, and actually come back here first, right? Because I want to show you something. In this region, okay, if we were to just allow the sky to streak, what's that mean? We're gonna turn off the tracking right here. So now the telescope is now letting the Earth rotate out from under the stars instead of following the stars. And for 20 seconds, we're just gonna take a picture. Here we go. Well, we're gonna get streaks. I just want you to see the quality and differences between the streaks. This is something you can do to actually see the colors of the stars, and to see how bright they are, and to see stars you didn't even realize were there. So let's take a look at that. Okay, now if you look at this, you notice that you see all these streaks. Here's Betelgeuse, of course. All right, and look at these streaks. Okay, here's an orangey star. This is a sort of a yellowish white star. This is a very white star. This is a yellowish orange star. Here's another orange star. Okay, you can see the colors very readily when you do this. And the best place to try this is when you have a field in the Milky Way of stars, and you do it, and it's just so rich. It's beautiful. But this is how you can see colors of stars. And I love doing that. That's really, really cool. So let's go back now, and okay, now we did this. Let's now go to our stellar program here, and let's now move over from Betelgeuse. Let's go to a little location up here. Yeah, I want to go right there. This rosette we're going to take a look at in just a minute. But first, I want to go to this little cluster right there. Okay? And we'll do that. Because sometimes the littlest things can tell us so much. Okay, so let's do this. Bring this up. We're there. Let's head east a little bit. Bring the stars over. Yep. And now let's do 20 seconds at 8,000. David, I know you're asking to do the question, but there is an app for the iPhone that will allow you to do somewhat of a time exposure, and I have it. It's interesting. It doesn't really do a time exposure, but it's cool, and you can check it out. I can probably give you the name. All right, so here we have this little cluster up here, right? And look at the richness of the star field. Isn't that beautiful? You know, and this is the field itself, and just a little more processing to kind of show you the richness of it. Just gorgeous. You'll also notice that right here there's a little nebula right here. See that red? That's actually a little nebula that's right there. And this is the cluster that we were aiming for right there. Just immense. You know, and there's so many stars. Any one of which has worlds around it. In fact, in this one little frame, there's probably maybe 100 planets, maybe 200 planets, maybe more, because we have very faint stars in the distance as well. You know, so you zoom in and then you can see stars that are ever fainter. Look, these two, and then this one. Look at that. This is just noise. This red and green fluff here. Okay. And you learn to differentiate that from stuff like this, which is actually a nebula. Okay. So it's really kind of interesting. It's just beautiful. And you know, I just never get tired of looking at beautiful stars. Do you? I don't know if you guys do. I certainly don't. Okay. So I'm just gonna bring back something here. Alright, so let's do this. Alright. So now let's go back to our planetarium. Alright, and let's take another look at, let's go down here. I said I would do the rosette, and I'll do it. This is an example of a cluster that the energy of the star cluster actually has driven a lot of the gas in the center away, so we don't actually see that illumination. We don't actually see, we just see the cluster here. We don't actually see the gas in the center of the cluster anymore. So let's bring this up. I want to drop us down a little bit. You'll see why in a minute. This upper part of the cluster is actually the most visible. It has dark lanes in it that are really pretty. So go a little bit east here, and then take a jaunt to the west. Okay, now let's do 16,000 at 20 seconds, okay? And we're off. Ronald in Jeffers, Minnesota is here. ERRT radio. You should listen to his station, a Mixler. Ronald is actually an interesting guy. He actually came out to see us at Pine Bush last year. He's coming out this year. And he bought himself a telescope. You know, I'd like to think I had something to do with that, but you know, he can tell you for sure. But I'm glad that he's getting into astronomy. It's such a beautiful science. There's so many beautiful things you can see. You know, let's see here. All right, so now let's. You can actually see a little bit of the. You can actually see the overall. There's a little bit of a shape here. You can see. You can also see these little dark snaky lines right here. You see that? Very hard to see. You know, can't really see them too easily. But those are dark lanes of dust that's actually in this nebula, right? And it's really a pretty nebula. Let's see if I can enhance it enough to bring it out. Okay, so now we actually see right here, you can see these little rivulets of dark dust. All this stuff in here, you see this fuzziness, that's all nebula. And this is the cluster. Notice how there's not much in there. These stars with their radiation powered a lot of that stuff out of the center. You know, and cause it to collide with other stuff out here. And these rivulets of dust are actually very prominent. You take longer exposures and you take them and stack them, and you get some gorgeous views of the rosette. And I actually have like the SkyTour LiveStream's greatest hits in one directory, which I'd be happy to show you at some point. I've done it before. So this is the rosette, and we could probably, if I were to take a bunch of photos of it, we could then stack them, and you see a more excellent result. But we're not. I don't want to do that tonight because we won't have the kind of time to do that. I want to move on because I want to find a few things. We always take a picture of Hubble's Variable Nebula when we can, because Hubble's Variable Nebula is an interesting little location, but it changes all the time. Because as the star that is causing this nebula to exist, as the star begins to rotate deep inside the cloud that you're about to see, it has dark matter around it, dark dust. And that dark dust will sometimes cause this nebula to look dimmer and have different shapes projected onto it. And every time we've taken a photo of it, it's looked different. So today, we do the same thing. Alright, we're going to go check it out. And right now, we'll do 20 seconds at 16,000 here. Let's see what we get. Alright. And this is Hubble's Variable Nebula. As we'll check it out. Alright, so it should be coming up now. And there it is. Look at that. So, here's Hubble's Variable Nebula, and a little processing shows it to you a little better. Check it out. And tonight, different from the other times. The other time we photographed Hubble's Variable Nebula, there was this little area that has a little bit of darkness in it right here. This was very dark, and it almost looked like it bisected the nebula. Well, this star that you see here is not the thing that's responsible for this nebula. Right? It's not responsible for lighting it up. This is a reflection nebula. It's not one of those hydrogen regions. It's just a reflection. And what's it doing? Well, it's reflecting off dust. However, the actual nebula is actually a result of excuse me. It's a result of a star that we can't even see illuminating this nebula from inside this dark dust in here. There's dark dust over here that you can't really see. It's called a dark nebula. And so it's illuminating the stars, it's illuminating this dust, and it has this orbiting dark matter around it. I mean just dark dust. And as it orbits around the star, okay, much like an asteroid belt orbits around, the sun, it casts different shadows on this outer area that we can see. And we actually end up seeing this change from time to time. That's why it's called Hubble's variable nebula. One of the favorite targets of Edwin Hubble, who also gave us the tuning fork diagram for galaxies, discovered the redshift and thus the Hubble constant, which is a mainstay in astronomical science for us. So, let me just check out the chat, see if anyone had questions that I might have missed. I'll do W. I had a snoring dog as well. She was a lab shepherd pit bull mix, and she sounded like a human being snoring. Absolutely crazy. Wow. Okay. So anyway, moving forward, let's go back to our wonderful view here, and actually go to the planetarium. So we visited Hubble's variable nebula. All right, and we want to go now. Let's go check out one of these clusters. Let's do the Headhunter cluster. These names are kind of funky. What's the Headhunter cluster? Well, it's actually known as NGC 2269. And if you're interested in this program is free. All this stuff is free. All right, and we can turn on and off lines and so forth, and object data. We can turn all the object data off if we so choose. Okay, like this. All right, but I like to use some of it so you can see what's going on. All right, and you can see information all the way down the side here. And that's really a good, again, for a free program, not bad. So, now heading over there, let's go over here. So we're moving a little bit more as we get to this cluster. You'll notice our north, south, and east and west cardinal points are not illuminated now. That's because the telescope is in motion. I can abort it by hitting that button, but if I leave it alone, it should lock in. And if it doesn't, then I will hit the button and we can move in and check it out. And that's what I'm going to do, because I'm not going to waste time. I don't want to waste time. Alright, so now move a little east. Alright, a little east here. And jog it west 1 notch like that. That's actually helpful because it allows us not to take care of something called backlash. Alright, backlash is when the gearing in the telescope allows the stars to drift a little bit before catching. Alright, let's do 20 seconds at 10,000. Alright, there we go. Okay. So you guys having fun time tonight? As we check out Orion's last gasp. It'll be the last time because next month it's going to be kind of tough. Because Orion's going to be setting. And we have a whole moon cycle that's starting up now. Here we go. Look at that. There's our cluster, but we want to actually show it, don't we? Yeah, see? That's cool. Yeah. So, see, that's really pretty. All right, that's really pretty. And this is a gorgeous cluster. Yeah. Yeah. Beautiful, beautiful. Beautiful, beautiful. You see a little bit of a sort of a little nebula in there, a round nebula, which I think is really cool. Actually, I have and the stars did walk a little bit. When you zoom in, you can see that they're a little bit elongated. But check out those colors, huh? The colors of these stars, you can see reddening and reddened stars as well. Really neat. I'm glad you guys are having fun, because I am too, or I wouldn't be doing it. So, let's check out one more thing here. First things first. I just want to come over here and make sure these views are live now. Over here here's a telescope view with our infrared camera inside the dome, and now the camera riding on the dome, riding on the telescope. Over here looking out of the slot. That's beautiful. Okay, good. Very nice. All right, so let's go back as we're cruising through clusters tonight, and let's do our, amongst other things, let's back out a little bit, and let's move down. If it looks like I'm in a hurry, I am. I want to make sure that we can see all these things for the last time, because the moon tomorrow, if it was clear, we wouldn't be able to see it, too easily, unfortunately. Yeah. Now let's go down to this little guy right here. Check that one out. Let's go watch us get there. Zoom. There we go. Now you can see why it's so important to have these cameras on, because I want to be able to watch and make sure that the telescope isn't crossing in front of the dome. Hey Keith, you're still here. Oh, great. Thank you, Keith. Did you want to come on? Keith, of course, is from P&K Space Imaging. Keith and I are very good friends, and we image together a lot, and we're part of Astro Imaging Live together with Bill New York Skywatcher. And it's really working on the website. What are you working on? Oh, I'm afraid to ask. That's fine. And so Keith, he's probably responsible for me doing what I'm doing now. He thought I should stream in the past, and I never had, and so this was my first attempt. I do a lot of talks around the country, of course, and a lot of television shows and stuff, because science needs people out there that are going to just say what's really going on. It's very important. I don't have an ego. I don't care who says it, as long as somebody says it. So when the shows come to me, they want a voice of reason. So the voice of reason being basically someone who can talk about science in a way that people can understand it, as well as bring some reason to the chaos of the UFO community. And that's a big one, so I like to be able to do that, and that's kind of, I view that kind of as my job in a way. Let me go into 4K mode here and just bring up the view a little bit. So this is a 80,000 sensitivity. That red you see around the border, that's actually the amplifier noise from the camera. But you can see very dim stars in here. I mean, very dim stars, and let's see, let me go back to this for 1 second. Oh yeah, that's the Planetary that I was looking for. Yeah. Okay. And so if I come back here, that's probably it. Okay, good. So now I'm going to cut this off and drop us down to about 15 seconds at, say, 8,000. Okay, and now make that 10 seconds at 8,000. Okay, now we're going to take a picture of this area, and I want to show you something that's hiding in here. All these things are hiding in the sky. And you know what? Some of these things really belie what actually happened there, you know. And we're actually looking at this little object right here. And you may think, well, hey, is that like Uranus or Neptune? No, actually, it's not. That's actually the remnants of a dead star. That's called a planetary nebula. And this nebula is the only thing left after a star died. Now, it's all alone out there. Look at that, amongst all these others. But the thing that's interesting is this planetary nebula. If there were planets in this solar system, this nebula is now bigger than the entire solar system the star system there would ever be. So it's probably got a diameter. Well, let's go see. We can probably figure it out. Let's just jump over here quickly to our thing here. What are we? This is Canis Major. It's a planetary nebula. It's okay, that's what I was thinking. Okay, it's 11,916 light years away. 11,000 light years away. I was gonna say that this object is about a light year across, and it's probably somewhere in that region. Meaning that the planetary nebula, that object we just looked at here, now reaches out beyond the entire confines of the star, and the whole star system may have been in here. What's that mean? It means that this hot gas, the reason we're seeing it is because the gas that was in this cloud of an expanding outer envelope of the star as it died was mostly oxygen. The hydrogen was there too, some hydrogen, but oxygen was there as well. And the oxygen gets ionized, and you'll notice that characteristic teal, bluish green color. And that is the doubly ionized oxygen atoms, and very characteristic of planetary nebulae. And that's what we're seeing here. The remnant of a dead star. And the glow would, of course, incinerate anything in the star system where this occurred. So any life there is not there anymore. You know, because the planet would have been vaporized. We actually, I might not. I'm hoping to be able to do SkyTour Radio tomorrow night on kgradio.com. The problem I'm having is my computer is very temperamental, the one I'm using right now, and I have to do some things to it that might really make it not work. It'll be the third week in a row, unfortunately, because I was actually away doing a talk in Las Vegas for some of that other time, so it might be problematic. And next weekend I'm going to be in Arkansas doing another talk, actually. And then in May I will be, of course, in Pine Bush. There's an outside chance that I have something in July and September, and I think the other months are filling in too, so there's a lot going on. But I want to be able to do my SkyTour Radio with, of course, Amanda as my co-host, and hopefully I'll be able to do it. But this computer has to work though, and what I'm doing now is not the same as what I need to do, for SkyTour Radio. It's much more, a lot more to it. Okay. All right, so there's a nice planetary nebula, 11,000 light years away. Wow. And we can see it from here. It must be bright. All right, so now this is Sirius, brightest star in the sky. All right, and I'll look at it. Why not, right? We should look at Sirius. It'll probably be one of the last times we can actually see it without moonlight. So let's go check out Sirius. So you can say you viewed the brightest star in the sky. There it is, pulling in. Pull that away for a minute. There we go. Okay, so obviously Sirius is here, and I can terminate that. Okay, and so now let's check out Sirius for just to show you what the brightest star in the sky looks like for 15 seconds at 8,000, okay? Which is kind of cool. So now we will see. All right, here we go. See that? All right, here's what happens when you photograph the brightest star in the sky. We see this halo, this unrealistic purple halo. We also see this over here. What is that? Is that a nebula? No. That's actually a lens flare from the brightness of Sirius. All right. Now, keep this in mind. If Betelgeuse, we looked at it earlier, Alpha Orionis, the orange star in Orion, if that supernova finally, if it went supernova already, being 490 light years away, it could have gone supernova. We're expecting it to. If it already went supernova, then the light train is gonna head away from the star, and that it's gonna finally reach us, and we're gonna see the light coming to us. Light isn't instantaneous. Light takes time to get here. The Earth is big enough so that light takes 1/7 of a second to go around the Earth, which means if you could steer light around the Earth, you could have it go around the Earth 7 times in a second. All right, that's over 20,000 miles in a second, or 7 times in a second. Or 1/7 of a second. So that's pretty cool. So, in any case, Betelgeuse light will be so bright when that light train finally gets here that Betelgeuse will be visible in the daytime sky. You'll see it in the daytime sky. In 1054 AD, the astronomers in China noticed a new star in the daytime sky and nighttime sky. And it turned out that was the Crab Nebula, the supernova remnant left over from a star that exploded. And that supernova remnant left behind a pulsar that is a very, very hot, spinning, rapidly spinning neutron star. And that neutron star, I think it spins like 13 times a second. Think about that. A star the size of Manhattan Island, and a little larger actually. Spherical star. Spinning so fast that it actually goes around in 1/13 of a second. Roughly. And that's not the record. The record neutron star that we saw was spinning at over 715 times a second. 715 times a second. Think about that. The amount of energies required to impart a dense core like that to such velocities is crazy, and that's the universe for you. It plays in the universe plays in the big boy sandbox, and it's just amazing what we see out there. It really is amazing. So getting out of here, you'll see Sirius is now quite low to the horizon. But let's see if we can grab a few more things here. What are we looking at there? Oh yeah, this is something we want to see. We want to see this before it's gone for good. This is an object called Thor's helmet. We've seen this before in SkyTour LiveStream. If you remember seeing it, say something, because I know that Thor's helmet is really beautiful, and the way its origin is actually really an amazing origin story. Thor's helmet's actually born of a star that's very massive that lost a lot of its hydrogen into space, and These stars very, very hot, and is known as a Wolf-Rayet star. That's wolf spelled like the animal, and Rayet, R-A-Y-E-T. R-A-Y-E-T. Oh, it's like E.T. phone home. Elliot. Remember that? E.T.? Well, anyway, so here we got that, and Thor's helmet is a really interesting sight, and I want to show it to you. It's really delicate and gossamer, and we're going to do it at 16,000 for 15 seconds. Right, here we go. I presented Thor's helmet, I think, to you guys on SkyTour LiveStream's Facebook page. And I actually did stacking of Thor's helmets. I did a bunch of them, took a lot of photos, and then stacked them, and then processed them so you could see exactly what Thor's helmet looks like. Alright, and you can see Thor's helmet here. Okay, it looks faint here, but you know, you let me at it. When I process it, it ends up looking far better, you know. This is a very delicate gossamer set of threads and filaments that are just beautiful. And we have some of that kind of thing, Planetary Nebula anyway, arriving in just another month or two in the constellation of Cygnus. We're going to be able to look at another supernova remnant that's called the Veil Nebula. Alright, so this is Thor's helmet. There's a star in the center here that's actually has a lot of radiation, pushing out radiation. This is oxygen atoms in the Wolf-Rayet star's world, and it's doubly ionized oxygen again, and it's pushing out this radiation, and then it's causing the atoms to glow by ionizing the electrons off, and then they recombine with the atom, giving off this characteristic glow. Very, very hot stars. I can't emphasize that enough. The stars are extremely hot, exceedingly hot. But that's Thor's helmet, and I know I'm moving fast, but I really do want to take you to a few other things before I have to give my voice a rest. I love doing this. I can't get enough. So, let's zoom out a bit. I'm going to go over here to the seagull. Let's try that. Okay, this object here is really hard to get because it's really low to the horizon most of the time. But I'm going to go there anyway and try it out. Let's see if we can see it. I know that we typically can, and we can see a little bit of that dark lane sometimes. And I think that's a really cool thing to do. Alright, so we're there. So I can do this, pull it over there, drop it back a bit. Okay, and let's do 20 seconds at 16,000 just to see if we can catch the Seagull Nebula. Dalai, the way we identify these elements is through their spectrum. We know that certain elements brought to certain temperatures will give off emission lines. That is, they'll emit characteristic colors, and they will also will generate a line in the spectrum of the star that will help identify the chemistry and makeup of the star. And that composition is something that is we've been very fortunate to have researched quite a bit, and we now know that this stuff is out there because of the spectrum we see coming from the star. We can actually identify it directly. You can see a little bit of the Seagull Nebula. It's really faint here, but you can catch it right there. You see that. That's really cool, and probably worth stacking a whole bunch of them, but I'm not going to do it tonight because I want to give you a few more things before I call it quits tonight. So let's see. We did Thor's helmet. We did that seagull. We back out. If you notice, there's like tons of objects here. You know, and again, this is the last of Orion. You know, here's one that I think you're really gonna like. And I'm kind of going downhill fast, so I may have to end here after only an hour and a half, so I apologize for that. But check this out. You are going to love this. Okay, this is a star cluster. Okay? Except there's something special, extra special going on in this star cluster. Let's go check it out, shall we? We shall. Now watch it. Hope the dome's not in the way. Let's go see. We might have a little bit, might have a little issue with the dome here. You know, it's worth going out to move it if it's in the way, because I just want you to see that. I really do want you to see that. All right, let's bring up this. Okay, we got our telescope back. Okay, pull that over. And anti-backlash movement. Okay, now let's do. We don't have to do that. We only need to do 15 seconds. At say 12,800. Here we go. So we're taking a picture of this cluster over here, and the way clusters are born is they're all born at the same time. So the stars all evolve at the same rate, roughly, and the same pace. So it's expected that all the stars in the cluster will be around the same age. Yeah, you just got the edge of the dome. All right, all around the same age. But look at this. In this cluster, we have this object right here. All right, and I don't know what that I don't know what that is. Right? You'll say, but we can tell what that is. And if you'll allow me, I'm going to run out and just turn the dome a little bit, okay? I'll be right back. I would actually, I haven't got my dome rotation mechanism in place yet. And that's a problem. But I really want to have a roll-off roof observatory. This is an actual dome, as you can see in the images here. All right. So this image here is of the object we want to see right there. And I'll explain that in just a moment. Okay, so I'll be right back. I'm just going to run out, fight off any coyotes, and then come right back. Be right back. Okay. Okay, I have returned. I have returned, thank you very much. So let's take a picture now again to actually show you this a little better. I've actually wanted to take a much nicer picture of this anyway. And I know that I can actually drop it down a little bit. Okay. Now let's take a 15-second picture, at 12,800. So, what we're looking at now is you see a star cluster, you know they're all the same, about the same age. And you also know they're young. These stars are young. How do you know that? Well, let's take a look at the picture, and I'll show you. Okay? If we look at this picture, all these stars, let me just get this figuratively done. Okay. There we go. So all these stars were in the same place, roughly. That means that they were relatively recently born in the universe, on the universal timescale. And the reason we know that is because they're still clustered together. Stars migrate away from each other. In some of the previous photos we took, you saw how there were just star fields around some of the other stars that we saw. And those were stars that were also born in clusters at one point and then just migrated away from their homes. And that's what happened with most of the stars in the sky. Now we look at this cluster. And this star cluster actually has this in it. A very odd object. Now, it shouldn't be there if this is a young star cluster, because what this is a dying star. You can even see the white dwarf in the middle there, okay, of this round object, okay? That right there, that's the white dwarf right in the middle there. It's still very hot, you know, tens of thousands of Kelvin, you know. So it's very, very warm, obviously, and it's causing the oxygen in this envelope that was puffed off of the star in its later years to glow. So how is it possible that this old star could end up in this cluster? Well, the way that could happen, okay, is if this star cluster and this object aren't even near each other. And that's in fact exactly what it is. So to answer your question, DW, if this is a remnant of a nova, it's not. It's actually a remnant of a star that kind of died on its own terms. This star here, right there in the middle, that's called a progenitor. That progenitor star in the center is what generated this nebula. As the star used up all its hydrogen, it started to puff up into a red giant, and then they're variable, and they kind of puff a little bit up and down, and kind of like smoke rings out into, well, smoke spheres out into space. They tend to blow off these outer layers, and when they do that, what happens is they end up having a hot inner core that gets exposed. In this case, this inner part of the star, probably now a white dwarf at this point. And what it does is its ultraviolet radiation bathes that gas, ionizes it. The electrons in that gas recombine with the atoms and glow, and cause this characteristic glow color, which is a color of doubly ionized oxygen. All right, so because the interstellar medium and stars make elements, they're element factories, and these stars here in this cluster were probably made with a lot of the elements that this star is showing. Okay, they probably have them in their atmospheres, even though they can't ever get hot enough to fuse them. So think about this. This object here, this star, is about 2,000 light years away. Say it's actually about that, but the cluster is 4,000 light years away. You see, it's a perspective effect. Okay, a perspective effect. So we see this, and it looks like it's superimposed on the cluster, and it's in the cluster. It's really not. It's way in the foreground. If we went racing for that cluster, we'd pass this halfway through our trip and keep on going. And that's when we would see that. That's when we would see this. So I think that this is probably one of my favorite clusters in the sky, because it's got a weird it's got this weird dichotomy going on here, where you've got this cluster of young hot stars and then this dying star supposedly in the middle of it. And I think that's pretty cool. So, well, all that said, folks, And I'm sorry that the stream's a little short tonight, but we did about an hour and 47 minutes, hour and 45, you know. And we saw a few objects. We saw the last gasp of Orion for the season because the moon is now getting brighter. Keith out there from PK Space Imaging, don't forget to subscribe to him, okay? And he has our link up there for Astro Imaging Live. Keith is now getting all excited because, see, the moon's starting to show up now. Ooh. And then he's going to want to show you all the moon. And he will do a great job with Paul down in Miami. And usually once a moon cycle, he'll have me on. And I think he'll have me on again. So I think it's pretty cool that, you know, we all support each other, by the way. So Bill New York Skywatcher supports Keith and I. Keith supports Bill New York Skywatcher and me. And I support Bill and Keith, you know. Bill's the reason that Bill's the reason that I actually have SkyTour Radio on kgriradio.com, because he pushed me to do that. And Keith is pretty much, and Paul are the reason that I'm streaming. So, hopefully, this is something that you have come to enjoy. It's something that we've come to really enjoy doing for you. Many times, Amanda, of course, who's my co-host on SkyTour Radio, will join me here too. But she's doing something else tonight and couldn't be here. But here you go. Again, this is a final, familiarity item here. When we do our streams, we have our live view in the middle, which again translates to the imagery that we see, like this. Okay, but we have our live view in the middle. We have our telescope cluster here, which controls the telescope. We have me down here in the observation dome ops. And that's important because it's important to kind of see the little bit of the human factor, what's going into this. We have our telescope cams over here, out in the dome, and we have our camera control cluster up here. So I had all this stuff framing our live view. And there's more that we're adding to this, by the way. And I think it's pretty cool. That we'll be doing that later on. I do have a spectral system on the telescope now, so we can actually see the spectra of these things I'm telling you about, so you actually understand what spectra are. But you know, I have to refine it a little bit more, just like I didn't just, you know, throw all this stuff out at you. I kind of eased into it. Because I wanted to make sure that the technology will all work together. And it did. So anyway, I do want to thank you guys for coming out and for hanging out with me for a little while. I had a great time, as always. I love hanging with you folks. You were phenomenal. Wonderful folks. I'm going to go and rest my voice. Probably drink a nice herbal tea. What do you think of that? You think that'd be a good idea? I think I like that idea too. You know? So I'll do that. And try and kick this garbage a little bit, you know. But anyway, thank you guys for coming out, and I shall talk to you. I don't know, maybe in another few days. If the moon is out early, if we get the early moon, that'll look kind of cool. The early moon should be a lot of fun. So, anyway, you guys have a good night, and I will talk to you a little bit later. Okay. All right, I will see you later.